So we have a working scientifically question here. So we've got a measuring cylinder containing water being used to measure the volume of a metal ring. And the first thing we're asked is what type of error would have been caused if the student's eye was not in line with the level of water. So we've got three choices. We've got random errors, which is, as the name suggests, an error that is a different size each time and can't be predicted. We've got a systematic error. That is something whereby the error is the same each time. So if you had, for example, an ammeter that read 0.1 before you started taking any measurements, every reading would be 0.1 amps out, and that would be a systematic error. That is also an example of a zero error. So a zero error is where our scale is reading non-zero when it should be reading zero. So zero is an example of a systematic error. A systematic error is one that will have the same size each time, and a random error is one that will have fluctuations in it. So if you're trying to establish the height of the water and you're not at eye level, you're not going to do that by the same amount each time, and therefore this is a random error. Then we're asked why the student would use a thin piece of string rather than thick to drop the metal ring into the water. Now this example here is using a displacement technique to allow us to find the volume of the ring. So what you want to know is that the height of the water that raises up is equal to the volume of the ring itself and nothing else. Now if the student was going to use thick string would have quite a big volume, and therefore actually the volume reading on the scale wouldn't necessarily be just the ring. So what we want to know here is the fact that thin string would affect the volume reading as much, or using a thin string would affect it less. Okay, because a thick string, we would have had a greater reading on the volume change, and that wouldn't have given us an accurate reading of the volume of the ring. Now we're shown some data and we're told what the true volume of the ring is, that 0.44 centimeters cubed. It says even without using the string, the cylinder could not give an accurate value for the volume of the ring. So accurate means close to the true value, and we're asked to give a reason why. Now if you look at the reading for the volume of the ring of 0.44, you'll notice that that is to 2 decimal places. However, if you look at the readings for the volume in the measuring cylinder, you will notice that both of those are only to 1 decimal place. So what we have here is that the measuring cylinder can't be used to 2 decimal places. Now the other thing you could use there instead is if you look at the graduations on the measuring cylinder, you'll notice that the resolution of the measuring cylinder is actually only 0.2. Okay, and therefore if the resolution is only 0.2 centimeters cubed, it will not be able to measure any greater than that. Then we've got the ring is removed and the reading on the balance is 0.02 grams. So they're using a balance to measure the mass of the ring, but once the ring's been taken off, the balance is reading 0.02 grams. So that is an example of a zero error. It is not reading zero when it should. How could the student use the readings from the balance to determine the correct mass of the ring? Well, if we know that the ring, or rather the reading, is 0.02 grams too big, then all we would need to do is we would need to subtract that 0.02 grams from the measured reading. Okay, then we're told that the student finds the density of the ring to be 21,500 kilograms per meter cubed. The volume of the ring is 0.44 centimeters cubed, and we are asked to calculate the mass of the ring. So from our formula sheet, we know that density is equal to mass divided by volume. We want to find the mass, so if we rearrange that, we know that mass is density multiplied by volume. But we've got an issue. Our density is given in kilograms per meter cubed, but our volume of our ring is given in centimeters cubed. So you have to firstly convert that 0.44 centimeters cubed into meters cubed. Now the way you do that is 0.44 centimeters cubed is equal to 0.44 times 10 to the minus 6 meters cubed. Now the reason for that is because if you imagine we had 0.44 centimeters, if we wanted to convert that into meters, that would be the same as 0.44 times 10 to the minus 2 meters. But because we have got meters cubed, what we are doing is we're saying, well, actually, we've got that to the power of 3. So we've actually got times 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2. And when we put all of those together, that is the same as times 10 to the minus 6. So when we then plug that in, we have mass is equal to 21,500 multiplied by 0.44 times 10 to the minus 6, and that gives us an answer of 0.00946, which can also be written as 9.46 times 10 to the minus 3 kilograms.